Hi. As I mentioned in the last clip, bivariate linear regression is all about modeling a relationship between two interval level variables. Excuse me. Let me turn my email off, or at least the sound. And part of modeling, fully modeling a relationship involves calculating, or finding, I should say, finding the line of best fit. And what we mean by line of best fit, and again, this is all presented in the quickest and easiest regression guide ever. What we mean by the line of best fit is the line that when passing through the data, as in a scatter plot, the line that when passing through the data has what's referred to as the least or lowest or smallest, the least summed squared residuals. Now that begs the question, what is a residual? Well, a residual sounds kind of fancy, but it's really not all that fancy. A residual is simply the space that exists between a case and a given line. Okay, so for example, I'm not going to cover every single case in this scatter plot, but the dotted lines that you see leading from those 1, 2, 3, 4 cases to the line that I drew, the arbitrary line that I drew, those are the residuals. So imagine, if you will, that we drew a line and that we took each case and we measured each case's residual. That simply means we've measured each case's distance from that line. Then we squared those residuals. We multiplied the residual by itself. Okay. Then we added all those squared residuals together, right? That would give us a number, right? I'm going to walk through that again. We draw a line. We measure the distance that each case falls from the line. We square each of those distances. We add those squared distances together. That would give us a number, would it not? Okay, so I'm going to label this line A, okay? And I'm going to say that line A, if we were to go through all that math, meaning drawing the line, measuring the residuals, squaring the residuals, adding the squared residuals together, and we come up with a number. And so hypothetically, I'm just going to say that the residual for line A is 10. Okay? Now, that might be the line of best fit. It might not be. I'm going to draw another line. I'm going to call this line B. All right? Maybe line B is the line of best fit. I don't know. Let's find out. Well, in order to find out, we need to take each case, measure each case's distance from the line. That's the line's residuals. Square those residuals, add those squared residuals together. That would give us a number, right? Let's assume that the summed squared residuals for line B is actually 12. Well, I know that A might not be the best fit, but A fits the data better than B because A has, hypothetically, I'm making this up as we go, A has a lower summed squared residual. Okay? I'm going to draw another line. I'm going to call this line C. And once I have line C, I'm going to assess or measure the residuals, and then square the residuals, and then add the squared residuals together. And lo and behold, let's say line C has a sum squared residuals of 8. That's the best fit yet, but we're not done. There's an infinite number of lines that can be drawn through a scatter plot, and we could go on. This would take us forever, right? Imagine how long it would take, even with just like a dozen cases or so, how long it would take to measure the residuals, square the residuals, add the residuals together, keep track of it all, and then once you have lines A through ZZ, or actually it'd probably be like A through ZZZZZZZ, because there's, as I mentioned, a nearly infinite number of lines possible, or actually technically speaking there is an infinite number of lines possible the way I'm describing it here. The line that had the lowest summed squared residuals would be the line of best fit. Lucky for us, we don't have to do it that way. We can find the line of best fit by using bivariate linear regression, the regression equation. The regression equation is going to allow us to find the line of best fit very quickly and relatively easily, at least relatively easily as it relates to this method here, which is just somewhat silly. Just a quick note before signing off for this particular segment. Some of you have been writing about, what did I do? What am I doing wrong? Like I'll get an email that says, "What am I doing wrong?" And that's a really difficult question for me to answer without a little bit more detail and without you pointing to a specific assignment, or better yet, pointing to a specific item or more than one item. It's a lot easier for me and Rhiannon and Lexi and our GTAs, other GTAs, to offer some help if we have a more specific idea of the kind of help that you need. So just a quick note. Next, we're going to move on to probability. That'll be the next segment.